Your brain is wired to see a baby when it looks at your cat, and science now knows exactly why. This video will show you the precise biological machinery, from anatomy to acoustics to touch, that makes your feline companion one of the most sophisticated emotional triggers in the natural world. And stay until the end, because there is a behavioral test you can run tonight that will reveal something remarkable about your bond. People who call themselves crazy cat parents are not dramatic. They are, without knowing it, describing a neurological response so ancient and so deep that no amount of modern logic can override it. That protective pull you feel when your cat curls into your chest. That ache when they are sick. That irrational joy when they choose your lap. None of it is weakness. All of it is biology doing exactly what it was designed to do. The domestication of cats began roughly 10,000 years ago along the Fertile Crescent. That part most people have heard. Here is what they have not heard. When researchers analyzed the skulls of ancient domestic cats against their wild counterparts, they found that the domestic lineage had undergone a measurable reduction in overall brain size, not a sign of degeneration, a sign of adaptation. According to Bradshaw et al., published in 2012, this reduction was accompanied by a shrinking of the adrenal glands, the organs responsible for triggering the flight or fight response. Wild cats are tuned for terror. Domestic cats were slowly, over millennia, retuned for something else entirely, for coexistence, for closeness, for you. But here's the part that should make you stop. That neurological rewiring did not just change how cats behave, it changed how they look. Domestication did not simply tame the wild cat's personality, it physically restructured its face. The technical term is neoteny, the retention of juvenile physical traits into adulthood. Wild felid adults have elongated muzzles, narrow foreheads, and eyes that are proportionally smaller relative to the size of their skull. Domestic cats, by contrast, kept the face of their own kittens, rounded cranium, flattened snout, eyes so disproportionately large for the skull that they violate every proportion you would expect in a fully grown predator. Think about that for a moment. You are not looking at an adult animal when you look at your cat's face. Anatomically, you are looking at a permanent juvenile. Now think about what your brain does when it sees that configuration. Konrad Lorenz, the Nobel-winning ethologist, identified what he called Kindchen schema in 1943, baby schema. He found that specific facial proportions, large eyes positioned low on the face, a rounded forehead, a small nose and soft jaw, trigger an involuntary caregiving response in human adults. Lorenz believed this mechanism evolved to prevent parents from abandoning helpless infants. The brain registers those proportions and releases oxytocin, the bonding neurochemical. It lowers cortisol. It shifts you into protective mode before you have even processed what you are looking at. Your cat did not stumble into those proportions by accident. Evolution selected for them. Cats that carried more neotenous features were more likely to elicit care from humans. More care meant more food, more safety, more offspring. Over 10,000 years of living beside us, the cats with the rounder faces, the bigger eyes, the softer expressions, survived better. The ones that looked more adult, more angular, more wild, did not hold our attention the same way. Natural selection, driven partly by human neurology, sculpted the face you are looking at right now. Drop your cat's name in the comments. Tell us how old they are. Because what comes next explains why your specific bond with your specific cat is not coincidence. It is the result of something far older and far more precise than either of you realizes. Here is where evolutionary biology gets quietly astonishing. In the wild, adult felids do not meow at each other. Adult lions, leopards, ocelots, and the direct ancestor of your cat, Felis silvestris libica, use vocalizations for mating calls, territorial warnings, and mother-to-kitten contact. But once a wild cat reaches adulthood, that kitten-to-mother vocalization, the small, urgent need me sound, disappears entirely. It is retired. There is no biological reason for an adult wildcat to produce it, because there is no adult wildcat that will respond to it. Then humans arrived. Domestic cats, through a process researchers now describe as targeted acoustic adaptation, reactivated and refined that juvenile vocalization and aimed it specifically at us. This is not a metaphor. This is a documented behavioral evolution. John Bradshaw of the University of Bristol, one of the leading authorities in anthrozoology, has argued that domestic cats are essentially operating in a permanent state of social neoteny, behaving toward humans the way a kitten behaves toward its mother. The meow is not a cat talking to another cat. It is a kitten, neurologically preserved inside an adult body, calling for its parent. Stop and sit with that. Your cat is not communicating horizontally, peer-to-peer. They are communicating vertically, dependent to caregiver. But evolution did not stop at simply reactivating the sound. It engineered the sound for maximum human response. A study conducted in 2009 by animal behavior researcher Karen McComb at the University of Sussex found something that should permanently change how you hear your cat. McComb and her team isolated a specific type of vocalization they called the solicitation purr. On the surface, it sounds like a normal purr. Underneath it, embedded within the low rumble, is a high-frequency cry component sitting between 300 and 600 hertz. That frequency range sits directly within the range of a human infant's cry. When McComb played this solicitation purr to human listeners, both cat owners and people who had never owned a cat rated it as significantly more urgent and more unpleasant to ignore than a standard purr. The participants were not responding to a cat. Their nervous system was responding to the acoustic signature of a baby in distress. Your cat knows this. Not consciously, not with calculation, but through 10,000 years of trial and error that ruthlessly pruned every vocalization that failed to move a human and preserved every one that did. If this behavior sounds familiar in your own cat, go ahead and give this video a like. Because what comes next reveals how this acoustic influence extends beyond sound and into the oldest language the body knows. A human infant cries. Your body tightens. Your attention narrows. Your hands move toward the source before your mind issues any instruction. This is not a decision. It is a subcortical reflex, processed in the amygdala and the anterior cingulate cortex, the same regions activated by pain and empathy. Neuroscientists call it the infant distress response, and it is among the most powerful, most deeply wired sequences in human neurological architecture. McComb's research on the solicitation purr demonstrated something that should make every cat owner reconsider every moment they have said, "My cat just wanted attention." The high-frequency cry embedded in that purr does not merely attract your attention. It activates the same neural circuit, the same tightening, the same forward lean toward the sound, the same neurochemical urgency. Your cat is not begging. Your cat is pressing a biological button that evolution placed inside you long before cats were ever domesticated. Picture this. It is 2 a.m. You are exhausted. The cat begins that sound, low and rumbling, with something underneath it you cannot quite name but cannot ignore. You get up. You feed them. You go back to bed feeling oddly satisfied. That is not weakness. That is a 10,000-year-old communication system working exactly as designed. But the acoustic channel is only one layer. There is a tactile one that reaches even deeper. Touch, for mammals, is processed through a separate neurological pathway than sight or sound. The unmyelinated C-tactile afferent fibers in human skin are specifically tuned for gentle, slow, social touch. These fibers do not respond to pressure or temperature the way standard nerve endings do. They respond to connection. They send signals directly to the insular cortex, the region of the brain involved in processing emotions, social bonding, and bodily self-awareness. When a cat rubs its head against your hand or settles its warm weight against your leg, those C-tactile fibers fire. Oxytocin rises. Heart rate slows. The nervous system reads the contact as safety, as belonging, as the presence of someone who will not let harm come to you in the night. Your cat is not leaning on you because your leg happens to be warm. They are triggering one of the oldest comfort systems in mammalian biology, and your body is responding to it exactly the way it was built to respond. Because here is what most people miss about that touch response. It does not just calm you, it calms them. The same C-tactile pathway exists in feline skin. When you stroke your cat in the direction of their fur, slowly, without pressure, you are triggering their own social bonding circuitry. You are not just receiving comfort, you are giving it. The exchange is mutual, biological, and ancient in a way that no amount of training or conditioning manufactured. It was inherited by both of you from ancestors who survived by staying close. Watch a kitten nurse for 30 seconds, and you will understand everything. The front paws press and release against the mother's belly, alternating in a slow, rhythmic motion that stimulates milk flow. The kitten's eyes are closed. Its entire body is relaxed. The motion is not voluntary in the way scratching an itch is voluntary. It is driven by a motor pattern embedded in the brain during the most formative window of feline neurological development, the first weeks of life when warmth, nourishment, and survival are the same word. Neurological studies confirm that actions performed during this critical period create lasting neural pathways that do not disappear after weaning. The association between needing, warmth, safety, and being fed becomes hardwired into the architecture of the feline brain. This is what you are witnessing when your adult cat climbs onto your lap, begins working their paws against your thigh, and enters what looks unmistakably like a trance. They are not performing a behavior. They are returning to the oldest memory their nervous system holds. Here is what that means for you. When your cat needs on you, they are not simply comfortable. They have categorized you, neurologically and behaviorally, as a maternal figure, as the source. The scent glands between their toe pads are depositing their unique chemical signature onto your clothing as they press. This is not incidental. It is territorial in the most intimate sense of the word, not aggressive claiming, but the kind of marking that says this person belongs to my world of safety. I am putting my scent on them so I never confuse them with a stranger. And how does a cat identify who gets that designation? Who earns the role of surrogate parent in the first place? Researchers studying feline social cognition have found that cats extend care-seeking behavior to individuals who meet a consistent cluster of signals: predictable presence, gentle touch, calm vocal tone, reliable feeding. These are the exact signals a kitten would use to identify a safe mother. Your cat is running the same ancient algorithm. They are not choosing you because you are entertaining. They are choosing you because you feel, to every deep layer of their nervous system, like home. That truth deserves a few more words. Because the most misunderstood thing about the cat-human bond is that it is often dismissed as projection, as humans imagining depth that is not there. But the biology does not support that dismissal. The neurological processes described here, the retained kitten behaviors, the acoustic manipulation, the tactile bonding circuits, are not interpretations. They are mechanisms. And when a mechanism is this precise, this durable across 10,000 years of coevolution, what you are experiencing is not imagined. It is real in the deepest sense that biology allows anything to be real. You are literally their family, not metaphorically, not sentimentally. In the operational language of your cat's nervous system, you occupy the same neurological category as the mother who kept them alive in the most vulnerable weeks of their existence. Every time they meow at you with that low, embedded urgency, they are calling for a parent. Every time they knead on your lap, they are nursing the memory of safety. Every time they press their forehead against your chin, they are scent marking you as part of their world, a world in which you are not just present, but essential. The stigma attached to deep cat love has always been a failure of information, not a failure of reason. When you understand the mechanisms, the neoteny, the acoustic hacking, the vestigial nursing reflex, the care-seeking algorithm running silently beneath every interaction, the love you feel stops looking excessive. It looks proportional. It looks like the only reasonable response to being chosen, at a biological level, as someone's parent. Your role is not to be a food dispenser. It is not to be furniture that occasionally provides warmth. You are, to the animal sleeping in your home, the figure their entire nervous system was rebuilt around. That is a weight worth carrying with intention. Before you go, if this changed the way you see your cat, subscribe. New behavioral science content arrives regularly, and each video builds on the last. Now, the test. Tonight, when your cat is calm and not actively seeking food, position yourself at their eye level. Do not stare hard. Let your gaze soften. Then slowly close your eyes. Hold them shut for 2 full seconds, and open again, just as slowly. That is the slow blink, what feline behaviorists describe as a visual trust signal, a deliberate lowering of your own alertness in a moment of vulnerability. If your cat blinks back slowly, you have just exchanged a phrase in their language that means "I feel safe with you." If they hold your gaze and then turn away calmly, that is also trust. In cat language, looking away from a non-threat is not disinterest. It is peace. You did not rescue a cat. You became a parent to one of evolution's most quietly sophisticated animals. And somewhere in that small, warm body pressed against you tonight, 10,000 years of coevolution is telling them, in every language biology knows, that they are exactly where they belong.